All right, so as we go through looking at different equations, we have to remember which domains have a restriction on them, because the domains that have a restriction on them can cause us to have extraneous solutions, not just full-out solutions. So right now, your two big ones that you need to worry about are square root and log. Okay? Okay, so that gets us to, remember, we got to figure out what type of equation we're going to solve. When we solved a quadratic, our plan was to set it equal to 0, then go through the series, carry out that plan, and then look back, which is basically checking it. On a quadratic, if my answer doesn't check, that means I mathematically made a mistake. But on a square root, if my answer doesn't check, it could be that that answer is extraneous. Okay? So you have to understand when they're extraneous and when they could be your own mistake. All right, so go to the exercises 1 through 10. There's 2 1 through 10s. We're on the second 1 through 10. Okay, so they've given me a numerical model. They've given me a numerical model and asked me to match it with a graphical model and an algebraic model. So I have a set of ordered pairs that I need to match with a graph and an equation. So if I put the dots like that, would it be a whole lot easier to match a set of ordered pairs to a graph? Yes. Find the ordered pairs. Not a problem, correct? But once you draw through those and the dots really become invisible, then you're trying to say, okay, well, that's about 3, 6, so is that on the line or is that not on the line? And in addition to that, these are not scaled by ones necessarily. So if your x's go from -2 to 14, then what is this scaled by? If this is -2 and that is 14, what is this scaled by? 2's. This goes from -4 to 36, so if that's -4 and that's 36, what is this scaled by? 4's. All right, so this one would be scaled by what? 1, and this one is scaled by. Now, do these scales look pretty close to each other? Does the scales of this and the scales of that look pretty close to each other? So if you're not reading this, you're not going to understand how it is scaled. Okay? So, if I take those dots and I actually make my own graph of them, here's 3, 6, here's 5, 10, here's 7, 14, here's 9, 18. If I make my own graph of them, is it easier to see that I am probably looking at a linear function? So now if I go back over here, y'all are looking at your graphs now. Which graphs are a linear function? A, B, D, G, and H. And my graph is going up 3, 6, 5, 10, so it couldn't be what? Couldn't be H, okay? So now I'm trying to decide, okay, well, which of those has a 3, 6, and a 5, 10, and a 7, 14. Kind of eyeball them and see which one you think it may be. It's really 3, 6, 5, 10, 7, 14, 9, 18. And you could probably convince yourself it's A. Let's try it from a different approach. Let's go to our models. How many linear models do we have over here? How many linear algebraic models do we have? Not linear. Not linear. Is O linear? Is O linear? Yes. Is Q linear? Is S linear? And P and T. Well, which one is it for sure not? O, because O has a what? Negative slope instead of a positive slope. So, would the linear model y equals 2x be 3, 6, 5, 10, 7, 14, 9, 18, 12, 24, 15, 30? If I plug in 3, am I going to get 6? If I plug in 5, am I going to get 10?
Yes.
So, would the linear model y equals 2x be the algebraic model for that numerical model that's on the other page? All right, now that I know the equation is y equals 2x, then which graph is it? It becomes blatantly obvious then which graph it is. Which one is it? D, the one that goes through 0, 0. So it really started with, it was easier for me to make my own little picture, so I had an idea what those dots were doing unconnected. Realizing that I needed a line, then was it actually easier to find the equation that fit before I tried to find the graph that fits. Okay? And it's just a matter of messing with what you have, but you've got to be able to interchange in between them and use the tools you have to make the best decisions to get to the plan that you need to get to. Okay? So, what kind of model would this be? Linear, quadratic, or square root? Square root. Quadratic. And what would be unique about this quadratic? It's going what? Down. Quadratic. This one. Quadratic. Now, if you weren't really paying attention, could you maybe convince yourself that this one's partially exponential as well? There's a little bitty sliver down there that starts going back up, but if you don't really look close, you don't see it. But how do I know that this is not exponential in this case? Because none of my answer choices are exponential. Okay? So, numerical, graphical, algebraic model. That's what they look like. That's not the only way they look, but that's a part of what they look like. All right, go to question number 30. Oh, wait, I got to do one more thing for y'all. Calculator. If you don't have graph paper, but you have a graphing calculator, you can also make a picture of that data. So that is my picture of 3, 6, 5, 10, 7, 14. Let me remind you how you get data in a calculator. You have to be on documents. You can't be on Scratchpad. And what do you choose to put data in the calculator? List and spreadsheet. So you got to choose list and spreadsheet. Name the first column. You skip that second line. Name the second column. Alright, now that's the ordered pairs. How do I make it look like dots? So you add a page, Control Doc. What kind of page do you think we should add? And that's where you all make the mistake. You don't add a graph page. Graph is putting an equation in. So if I wanted to graph y equals 2x, then I would choose graph. If I want to look at the ordered pairs, I have to choose data and statistics. So list and spreadsheets to get it in, data and statistics to look at the graph. And that one's X. And that one's Y, and then it'll arrange them for you. Okay, so it's listed spreadsheets and data and statistics, not graphs. Okay, go to question number 36. Go to question number 36. All right, so I want to solve 36. What kind of equation is 36? A quadratic. So what's the first thing I want to do in order to solve a quadratic equation? Set it equal to 0. Can I drag everything this way? Can I drag everything that way? I'm going to recommend you drag everything this way so that A stays what? Positive. So if I pull this over here, minus x squared, what would I get? Plus 3x is going to give me what? And minus 4 is going to give me negative 12. Now, does it matter that even though I drug everything over there that I wrote it backwards? I mean, is 0 equals that the same as that equals 0? All right, well, let's factor. What? Negative 6 and positive 2. Which then makes my solution 6 and negative 2. If I plug them in, should they both check? And if they don't check, is it because they're extraneous or because I made a mistake? What's the domain? All real numbers. So if they don't check, it's your mistake. It's not because they are extraneous. Okay? All right. 37. What kind of equation? Square root? Do we have the same plan for square root that we have for quadratic? Because it's already set equal to 0, so are we already accomplished step 1, or is it a different step for square root? What's usually the first thing we do or try to do in order to solve a square root equation? Isolate the square root. Not set it equal to 0, but get the square root by itself. So I need to move that x over, move that 1 over. Then I need to so this would become positive x over 2 and positive 1/2. All right, now I have the square root by itself. So then what do I do? Square both sides. Here's the easy side. What does squaring this side mean I really need to do? Does it mean square this and square this, or does it mean multiply it times itself? Which then means we need to do what to it? FOIL it, right? We need to FOIL it. All right, so what is x over 2 times x over 2? X squared over 4. What is x over 2 times 1/2? X over 4. What is 1/2 times x over 2? X over 4. What is 1/2 times 1/2? 1 over 4. Please do not make multiplying fractions complicated. How do you multiply fractions? Multiply the tops, multiply the bottom. Okay? All right, so now I've got rid of the square root, but in the process of getting the square root, I created a what? An x squared, which means I'm back to a what? Quadratic. So now do I need to set it equal to 0? Okay? So I can add these two together. What is x over 4 plus x over 4? It's going to give you 2x over 4, right? And I know it reduces, but I'm going to purposely leave it like that because right now, do I have the same denominator on all of them? Which will make my life easier momentarily. Okay? So if I subtract an x from there and subtract a 4 from there, if this is currently x over 1, to subtract these, I have to have a what? Common denominator. So if I change this to a 4, the top would become what? Negative 4x. So 2x minus 4x would be over 4. If I change this to a 4, this top would become 16. So 1 minus 16 would be negative 15. And I could leave it like that. Or I could just take this whole thing equation and multiply by 4, and would that be a much easier version of a quadratic to solve, getting rid of all of those fractions? So why did I multiply by 4? Because the denominator was 4. What if this had been an 8 and this had been a 6? Would multiplying by 4 fix that? What would I need to multiply by? 2 is not going to fix it. Because 2 is going to be 2 over 4, which is going to reduce to 1/2. 2 over 8 is going to reduce to 1/4. 2 over 6 is going to reduce to 1/3. So I just went from 4, 6, 8 to 2, 4, 3. That didn't fix anything. What would I need to multiply by? Somebody said it. 24. If I multiply them all by 24, then do we have something bigger on top so that the fraction actually goes away? So if you're going to clear a fraction, does it have to be as big as your bigger number or bigger? You can't go smaller. Otherwise, you're just going to have reduced fractions instead of the fractions that you have. All right. Will this factor? Will anything multiply to negative 15 and add to negative 2? What? Negative 5 and positive 3? Which would then make my solutions what? 5 and negative 3. All right, so now here's my dilemma. I'm going to go check. If it doesn't check, does that mean I automatically made a mistake, or could it be that it's extraneous? Because what was my parent? Square root, which has a restriction on its domain. So when I plug the 5 in, 5 plus 1 minus 2 square root of 5 plus 4. Well, what's 5 plus 4? What's the square root of 9? So do I have 5 plus 1 minus 6? And what is 5 plus 1 minus 6? 0. Okay? If I plug in negative 3. Whoop. Trying to be able to see it all. Negative 3 plus 1 minus 2 square root of negative 3 plus 4. What is negative 3 plus 4? What's the square root of 1? So I have negative 3 plus 1 minus 2. Is that going to give me 0? Is negative 3 plus 1 minus 2 going to give me 0? No. So this solution is extraneous. that solution is extraneous. All right. Now, along with those instructions, it said to, forget the word it used, confirm those solutions graphically. So how would I confirm these solutions graphically? So let's go back to the quadratic. That was, where did my quadratic go? Use the 6 and 2 after I put it together. Dang it, it was just sitting right here. I think it was this one. I just didn't write it down. I wrote it down on another piece of paper. So those were my solutions, 6 and 2. So if I want to confirm that, does that mean I just go, oh, put a dot at 6 and put a dot at -2 and I confirmed it? No. It means I need to make an actual graph of it using some other method. And when I'm finished with that graph, that is not 2. This is 2 over here. When I am done with that graph, should my graph pass through the point 2 and 6 without knowing that it should be at 2 and 6 before I get there? Okay? So confirming your graph doesn't mean to use your solutions to graph. It means graph it to make sure the graph is really doing what at those numbers? Crossing the x-axis of those numbers. Okay? All right. One more problem. Number 41. Number 41. What kind of equation is this? Absolute value. What's the domain? Our real numbers. Do I got to worry about extraneous? No. All right, so quadratic we set equal to 0. Square root, we get the square root by itself. What do we need to do for absolute value? What do we need to do for absolute value? You want to get the absolute value by itself. So which absolute value? There's 2. So let's start simple. What values of x will make that equation true? 7 and -7. So that tells you we need 2 answers, correct? What would make that true? 6 and -8. Okay. So here's, is that the real bill? All right, we'll pick up there tomorrow.